Good morning and welcome back to my channel, and today and over the next few videos we're going to be going over differentiation by first principles of some fairly common functions. So today we're going to be doing that for sine x. So if f of x is equal to sine x, then f dash of x will be equal to f of x plus h, which in this case is sine of x plus h minus sine x, or just f of x, all over h, and this has the limit as h tends to 0. Technically this should be over here, but I haven't drawn that in early enough, so I will rectify that in the next line. That will be equal to the limit as h tends to 0 of sine of x plus h. We're going to use double angle formulae. So that's going to be sine x cos h plus sine h cos x. And I'm going to put that in brackets to implicate that that is from sine x plus h minus sine x all over h. The next line will be the limit as h tends to 0 of, take out a factor of sine x cos h minus 1 minus sine h, so plus sine h cos x all over h. Now, as h tends to 0, sine of h will tend to h. And the way we visualize this is the sine graph, which looks something like this. And it will just keep on going forever. But if sine is tending to this point here, to 0, the value is tending to 0. So it makes sense that sine h tends to h as h tends to 0. Next, we need to know that as h tends to 0, cos h will tend to 1 minus h squared over 2. That I don't have an explanation for in this video, but I may go over it in the future if you ask me in the comments. So, this expression up here will be equal to the limit as h tends to 0 of sine x times, if we substitute our limit in here, this thing in here, the ones will cancel, and so we'll be left with minus h squared over 2 here, plus sine h will just tend to h, cos x all over h. Now, I'm going to use the limit here, and this h will tend to 0, so this whole term, the sine x times the h squared bracket, will all leave. Then I can cancel these h's, and it will now be 1 times cos x as the limit of h tending to 0, but I no longer have any h's. So this will just tend to cos x, which is the derivative of sine x. Thank you very much for attending this video, and I will see you next week.